All right, if you remember, we did discuss the roller coaster, and we rode on a roller coaster ride, and we talked about the way that your body moves when you're on the roller coaster. For instance, when you're going up that hill, which way does your body move?
Back.
Back. When you're going down the hill, the first thing before you get down that hill, what does your body first do?
Sit still.
You go kind of up.
There you go.
Yes, you do. When you first go down the hill, your body lifts up, and then you kind of
Keep going.
go forward. Your body goes forward. When you turn to the right, which way does your body go? Left. When you turn to the left, which way does your body go? Right. And your body does all of this because at first you are at rest. Put that table down. And when an object is at rest, it wants to stay at rest. Why?
Until,
Why? Because it's lazy. Why? Who said that? Newton. Which law? Newton's first law. But not only did he say when an object is at rest, it wants to stay at rest, he also said, which is why when you stop at a roller coaster, an abrupt stop, what does your body do? You go forward, which is why you need to wear your seatbelt. In discussing the parts of a roller coaster, what's happening is this. There is a reaction force which causes the cart to go down the hill and your body lift up and you to go forward. There is also a friction that is kind of pulling on the cart for a moment, which stops you from flying off the track. There is also weight. The weight of the cart is going to determine how fast your roller coaster is going to go down that hill. And when people who are designing roller coasters, you have to think about friction. And friction is what? Raise your hand. What is friction? You give me an example, but I want to know the definition. You all should know the definition because you have. You all should know the definition of friction. What is it? That is an example of friction. Friction is what? You all should be in your notebooks looking at your dictionary or at your reference book. You should be. Kids, you don't move. Just raise your hand. If I call you, that means you're going to give me the answer right now. Kieja. Now. No. Naya. What does resistance mean? What does resistance mean? Like a lot of you resist to follow directions. It's pushback. You kind of stop. So friction, it allows things to not move as fast. For instance, there is not a lot of friction if you're walking on ice. Why? Why do you know there's not a lot of friction?
You slide around.
Because you go slipping around. So people who are designing roller coasters, they have to think about the weight of the roller coaster cart and friction. When you go down a hill and then you got to get back up that hill, they have to think about the centripetal force, which allows the cart to get back up that hill. Come put your hand down for a second. I'm not asking questions or answering questions just yet. It has to think about that cart getting back up that hill, because if that hill's too high, that cart's not going to do what? It's going to stay right in that low spot, and you're going to be stuck. It's not going to get back up that hill. So they have to think about that. The same thing is another centripetal force which pulls down on it, allows it to go back over another hill. The size of the force is going to determine all those thrills and trills that you get when you're riding a roller coaster, and they have to think about those things so that you don't get sick. Because if you're riding a roller coaster and a lot of people are riding it and everyone's getting sick, it's not a good roller coaster. They have not thought of the scientific portion of making that roller coaster. So, on your sheet that says force and motion and mass, let's look at this. Everyone should have this paper in front of them and your pencils should be up. Now your problem is, what is the relationship between force, motion, and mass? Research means that you're doing what? You're thinking. And one thing you're thinking about is which Newton's law should you be thinking about? Don't answer me. Just write it down. Get your foot off that table. Don't tell me, write down which law you're thinking about when we're talking about force, motion, and mass. Get in your book and see which law you should be thinking about when we're talking about mass,
The first one.
force, and motion. Don't answer me, write it down. What is motion? Movement, moving. Hands up. I need to be right. Seneca, what law do you say we should be thinking about? Seneca says the second law? Does everyone agree with Seneca?
Yes.
No.
No, absolutely not. Raise your hand if you agree with Seneca.
Oh, yes.
Raise your hand if you disagree with Seneca. The majority of the people agree, so we're going to stick with the second law. All right, for your hypothesis, when we're discussing relationship, we're thinking about if something increases or decreases. Put that ruler down. So we're talking about the relationship between force, motion, and mass. So we're thinking about if force does this, motion and mass will do this. Or if motion does this, force and mass will do this. So let's say, start off with if mass is increased, when Miss Wiggins is writing,
Usually writing. Should be writing.
very good. So let's start off with thinking about if mass is increased, because we're talking about relationships. So we want to know what's going to happen with other things if we increase mass. I'll be in practice. No, I will be. So now mass means the what of an object? The amount of matter in the object. If we increase the mass, that means we made it not necessarily bigger, heavier. We definitely made it heavier. Because when you say bigger, this obviously is bigger than a book, correct?
Yes.
But does this have more mass?
No.
The tub does not have more mass than the book. Why does the book have more mass?
Because it's heavier.
Not because it's heavier. Exactly, it has more matter. There's more stuff in the book than there is in this tub. So bigger does not necessarily mean more mass. It means the amount of stuff that's in an object. So if something has more mass, meaning that it is heavier, what will force be? Will force have to increase or decrease?
Increase.
Increase.
Okay, you say, how many of you agree with increase? How many of you disagree with increase? Listen to the question again because some of you did not raise your hand. If mass is increased, meaning if it's heavier, will we have to increase the amount of force or decrease the amount of force? I just asked two things. Raise your hand if you say increase the amount of force. Raise your hand if you say decrease the amount of force. Okay, so the majority said increase. So if mass is increased, the amount of force needed is increased. You should be writing. Motion is what? Movement. So if something is heavier, what will happen with the motion? Will motion increase or decrease? You say, how many of you say motion will decrease? How many of you say motion will increase? Okay, the most said motion will decrease.
Most of us.
1 second. Teresa, you just don't learn your lesson, do you? Yes. So that's our hypothesis. We don't know if it's right or wrong yet. It's a educated guess. Would you say we used our education to make that guess? Okay. Any questions so far? Does everyone have that written? Okay. Can I move? Okay, a couple more seconds. And your partner has it, so. Yes. You have to wait a minute. No, don't ask me again. Don't ask me again. No, you're gonna act better, period. All right, here's our procedures. We're going to have 3 people, I think 2 people, and in 30 seconds, person 1 is going to count the number of lifts. Then we're going to increase the mass, and in 30 seconds, we're going to see how many lifts. Then we're going to increase the mass again and do the same thing, and increase it again and do the same thing. Then we're going to have person 2 follow those same procedures. While we're doing that, we're going to be recording our data. Any questions so far? Okay. We're going to increase the mass by adding numbers of books. And actually, I'm going to put a timer on the screen. Yes, I'll just leave my timer here. Can I have a volunteer? Gabriella. Gabriella has this bag. How many books are in the bag? 0. So 0 books are in the bag. We're going to see how many lifts she can do in 30 seconds. You can lift it with 2 hands or 1 hand, but every time you have to do it the same way. So how are you going to lift it? With 2 hands or 1? 2 hands. So you'll take it in front of you, and you have to lift all the way up to your chin. Okay? And you have to do it in 30 seconds when I say go, stand in front of the class. Are you ready? Okay? Go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, stop, 26 lifts. Procedure number 2 says we're going to increase the mass.
Oh.
We're going to increase the mass by adding 4 more books. 4 books. Don't start yet. No. So now we have 4 books. Each book is actually about 500 grams. So she has 2,000 grams that she's lifting right now. Are you ready? Okay, go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17,
Not yet, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. She made 26. Now we're going to increase even more. There are 7 books in this bag. 7 books. Are you ready? And go.
1, 2, 3, 4, 5, 6,
You have to hold the same way. 6.
7,
Keep going.
8,
2 more, 2 more.
9,
1 more.
10.
Only 10 left. Maggot, let's give Gabriella a round of applause. May I get another volunteer? Kayla. Okay, Tessa. Caleb, you're gonna lift it with one hand.
One hand.
You're gonna lift it with one hand by doing like this. You have to bring it to your chin. As you feel like you need to. All right, Tessa. Sit down. We're wasting our time. No, we're gonna have him. No, because this is what our procedure says. Right now, Caleb has 0 books. Sit down, and I don't. With that comment, you never get paid. 30 seconds on the clock. Are you ready? And go. 1, 2, 3, 4. We're just counting. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16,
17, 18, 19, 20, 21, 22, 23,
She got more than you.
25. No, 5. Guys, it's not a competition. Don't forget what we're doing this for because we're looking at the relationship between force, motion, and mass. It's not a competition. Now we're going to add 4 books. And not to mention, he's only lifting with one hand. Anaya. Naya, did you just make a comment about what he could and could not do? No, he's doing only one hand. Because we're doing an experiment, we're making a point. One hand, are you ready? To your chin. Quiet. All we're doing is counting, and we're not criticizing. And go. 2. All the way down. Stand up straight. Stand up straight. All right. Keep going. 7, 8, 9, 10, 11, 12, 13. And we have to say one hand. On your class, on your sheet, you need to write what I wrote. He's using one hand. She's using 2 hands. Let me ask you a question before we go on. Does one hand versus 2 hand, which one is more force? 2 hands is more force because you have more what? Force is a what? Force is what? So 2 arms is more what? More of a pull, not a push, but more of a pull. All right, now we're going to go with 7. Look. Thank you.
Prove them wrong.
7.
At least do one, Caleb. At least do one.
Are you ready? And go.
Caleb, do 5.
Not one. 2. That was only 1 because he didn't really get the other one up. 2.
4. Come on, Lee. You got 3 more. You got 3 more.
Get 10. 5. Hurry, real fast. 6. 7. 8. 9.
That's it. Time's up. Good job. Let's give Philip a round of applause. Pull up, stand up. Pull them up. Pull up, stand up. Clap, clap. We will not have any time at the end of class. Looking at our data, Gabriella used more force to begin with. The amount of lifts is calculating what? Is it calculating force, motion, or mass?
Force.
This is definitely calculating force. It's also calculating, this is mass here, force and motion. When we say it's calculating motion, did she need more force as we went along? Yes, because it took her a longer time to get them. Because it took her a longer time, how did her motion? Did it increase or decrease?
Decrease.
Her motion definitely decreased. She was not able to move as fast. So now we have to answer our analysis, answer our original problem. The original problem stated what? Someone read the problem to me. Brianni.
What is the relationship between force, motion, and mass?
What is the relationship between force, motion, and mass? Well, let's start with mass because we increased mass as we went along, correct? We increased the number of books. So, answering the question using this information, when mass is increased, which is what we did, correct?
Yes.
What happened, Gabriella, you should be writing. What happened to force? Was she giving it more pull?
Yes.
She gave it less pull to get it up there? You saw her straining, and the same thing with Caleb. He started to actually put his other arm on his other arm to give it more pull, to give it more force. So when mass increased, force did what? Force increased or decreased? Force increased.
Wait, is that force?
Yes, it's a capital F. And motion did what? What did motion do? Motion decreased because it took them longer, or they didn't get as many lifts in the same amount of time. So in order to get the same amount of lifts, they would have needed more time. They did not get the same amount of lifts. So therefore, motion decreased. And the way we know motion decreased is because they did not get the same amount of lifts. 1 second. Keep working. Does everyone have this?
Yeah.
So, then your conclusion would say what? My hypothesis was correct. Your hypothesis was correct. Sweetheart, copy your... So your conclusion was, my hypothesis, we should not be talking, was correct. Rakesh, do I need to call your mother? My hypothesis was correct. And this should say,
Was your hypothesis, not was.
which Newton's law does this demonstrate?
Second.
What?
Third.
First, an object in motion will remain in motion unless that has nothing to do with that.
No, third.
What does third law say? What does the third law say?
Every reaction calls for an action.
Exactly. Good job, Dylan. Every action calls for an opposite or equal reaction. What does the second say?
Object in what direction?
That's the third law you're thinking of. Naya, what does the second law say?
The amount of energy needed to make an object change its velocity depends on the mass of the object and the force required.
What law is this? Second, because the amount of energy is the amount of work you're doing, amount of force needed. So what else did it say? The amount of energy needed to change the velocity, which is the rate of something over time, the speed over time. Keep going.
The velocity depends on the mass of the object.
Depends on the mass. The less mass, the faster they were able to lift. The more mass, the slower they could lift, and they needed more force. So this definitely is Newton's second law. Any questions?